Let us continue alcohols. Preparation of alcohols we'll see. Now we'll take alkenes. This alkenes undergoes this alkenes is taken for hydroboration, then oxidation. Hydroboration, then oxidation. What it will give in the sense, it will give alcohol. Sir, okay. Now we will take alkene. Alkene is so and so. Hydroboration in the sense treating with the diborane in the presence of THF solvent, tetrahydrofuran. Okay. So diborane, when it is involving in chemical reaction, it becomes what in the sense it becomes BH3. So how the chemical reaction takes place, we'll see. This alkene will take. So alkene we have taken like this. And in the diborane, boron part goes towards lesser hindrance side. Lesser hindrance side means in the double bonded carbon, this is giving less hindrance. That side boron goes. Hydrogen goes towards the double bonded carbon, which is giving more hindrance. Okay. Then BH3 will give like this. Now shift of electron cloud takes place. Shift of electron cloud means this electron cloud goes like this. This electron cloud goes like this. Therefore, what we will get here? That is RCH. Here H comes here single bond, here CH2, here boron making a bond like this. Okay, boron making a bond. Therefore, between boron and hydrogen bond is broken. Okay, so it is called what in the sense here one alkyl group is there. Therefore, it is alkyl. We can say this. We can say borane. It is we can say borane. This we can say diborane. This we can say diborane. In this diborane, 2 times BH3 group is there. Therefore, diborane. Here only 1 time BH3. Therefore, borane. In that one of the hydrogen alkyl group is there. Therefore, alkyl borane. Okay. So now we can say that here in this borane, one hydrogen is replaced by what in the sense alkyl group. In the same way, this hydrogen also replaced by alkyl group, that we'll see. So our CH2, this boron, we having one hydrogen. This hydrogen also replaced by one alkyl group. Okay, so one alkyl group is replaced. Next, this hydrogen also replaced by one alkyl group. So our CH2, here boron, here CH2, or here we can say CH2, or we can say. Okay, this is called what in the sense trialkyl borane. Okay, this we can call it as trialkyl borane, we can call. Okay, so trialkyl borane, we can call this is as a trialkyl borane. We can say this boron is having 3 bonds here. It is trigonal planar. Okay, this process is called hydroboration. This is called hydroboration. Why it is called hydroboration? In the sense here hydrogen is added, here boron is added. Therefore, it is called hydroboration. Then we will take this hydroboration for oxidation. This trialkyl borane will take for oxidation. Will take. Okay. Now we will go for oxidation. Okay. Now we are taking trialkyl borane. This is taken for oxidation. That is hydrogen peroxide and sodium hydroxide is taken. Now oxidation is possible. Okay. Now hydrogen peroxide we can write like this. Sodium hydroxide we can write like this. So what happens means here water is removed. Therefore, what is produced in the sense hydroperoxide is produced. This what in the sense hydroperoxide is produced. This hydroperoxide is attacking this trialkyl borane. Now we have taken this trialkyl borane. We have taken this hydroperoxide is attacking. How it is attacking, that we will see. This lone pair is attacking this boron. Okay, so lone pair is attacking the boron. Therefore, we will get what we will see. So R CH2 there boron CH2 or here OOH, here CH2 or like this we have written. Okay, oxygen will get, boron will get negative charge. Boron is getting what charge? In the sense a negative charge, we can say. Sir, okay. Next, what is happening? Next, what is the structure that we will see? Next structure, what happens? You see, this this bond is migrating towards this carbon, that is attacking this oxygen. This bond is migrating towards this side. Okay, so what we will get, we'll see. So RCH2 CH2 single bond boron. Here O minus will be there, O minus will be there. Then CH2 CH2R. Okay, then what is another substance in the sense, this is what in the sense R CH2 CH2 OH. Okay, this R CH2 CH2 OH we are getting. Okay, then next what is happening means this O minus takes H plus from water. This O minus takes H plus from water, therefore it becomes OH. That becomes OH, CH2 CH2R. Here also CH2 CH2R. Okay, next step, again hydroperoxide is attacking. Like then this group is converting into alcohol. Instead of this group OH comes. In the same manner this also, therefore finally it is converting into boric acid. Finally it is this boron is converting into boric acid. So what we got in the sense, this is a product. So what is the product we got? This alcohol we got. That means boron is replaced by OH group. Therefore, this point is called oxidation, we can say. Okay. So here, what is a reactant? Reactant is this alkene. Alkene is a reactant. Okay. So what is a reactant in the sense? RCH double bond CH2 is the alkene is the reactant. What is the product in the sense? RCH2 CH2OH. Okay. Therefore, to this carbon, what is added means hydrogen. To this carbon, what is added means OH. This is called anti-Markovnikov's product, we can say. Anti-Markovnikov's product. Therefore, hydroboration oxidation gives anti-Markovnikov's product. Then here hydrogen is added, therefore CH2. Here OH is added, therefore this process is called hydration. This process is called hydration, we can say. So this hydroboration oxidation means alkene undergoes hydration. What is the product in the sense? Alcohol. This alcohol is as per what in the sense? Anti-Markovnikov's product. Anti-Markovnikov's product. As per that we will get the product here. Therefore anti-Markovnikov's product we are saying. Okay. Then here, rearrangement is possible or not in the sense, for a rearrangement case, there is no possibility. So, no rearrangement here. Okay, rearrangement is not possible. Okay. Next, in the preparation of alcohols, we will go for a reduction. In the using reduction method, how to prepare alcohols, that we'll see. So, preparation of alcohol by what method in the sense, reduction. Okay. So, now we will consider what in the sense aldehyde we will consider. Okay, we are considering aldehyde. This aldehyde is taken for a reduction. What we are getting in the sense alcohol we are getting. We are getting alcohol. So aldehyde we will write RCHO. Aldehyde we are writing RCHO. Here how the bond is breaking in the sense pi bond is breaking. This side 1H, this side 1H. So we are getting alcohol. So what is a reducing agent we can use here? What is a reducing agent? What is the reducing agent we are using for this reduction? One is lithium aluminum hydride ether. Lithium aluminum hydride in the solvent ether. Next one is catalytic reduction. That is nickel or platinum or palladium plus hydrogen. This is catalytic reduction. Next one is sodium borohydride. Sodium borohydride in the solvent ethanol. In the solvent ethanol. Then diborane. Diborane in the solvent THF. Diborane in the solvent THF. Next, metal plus acid. Metal plus acid. Suppose zinc metal plus acid. Like this we can take. Zinc metal plus acid. Zinc metal plus acid. Next, alkali metal plus alcohol. Alkali metal in the sense sodium we can take. Alkali metal plus alcohol we can take. Alkali metal plus alcohol. Alcohol in the sense ethanol. Alkali metal in the sense sodium. Therefore, sodium ethoxide. Sodium ethoxide. So these reducing agents we can use for converting aldehyde into alcohol. So okay. Next we will see ketone into alcohol. Now we will take ketone. Ketone will convert into alcohol. That alcohol is like this. So ketone into alcohol. So how it is converting, that we'll see. Ketone will take now How it is reducing? This pi bond is breaking, here 1H, here 1H, therefore we are getting this alcohol we are getting. Now what is a reducing agent we can use for this? Means what reducing agent we are using for aldehyde into alcohol, same reducing agent we can use for converting ketone into alcohol. Sir, next we'll see carboxylic acid into alcohol. Carboxylic acid into alcohol we'll see. Carboxylic acid into alcohol, that point we'll see. So carboxylic acid we can write it as a R C double bond O single bond OH. Okay. Now how the bond is breaking we'll see. Here one pi bond is breaking, 1H, 1H. This sigma bond is breaking, 1H, 1H. Therefore we are getting RCH2OH. This becomes water we can say. What is a reducing agent we can use for this reduction? In the sense lithium aluminum hydride in ether we can use. Lithium aluminum hydride in ether we are using. Then diborane in THF we are using. Diborane in THF. Diborane in THF we are using. These two reducing agents we can use for converting carboxylic acid into alcohol. Then next one is ester. Ester into alcohol, that we will see. Ester into alcohol. So ester will write it as a R C double bond O single bond O single bond R dash. Now what is here? This pi bond is breaking, here 1H, the here 1H we can say. This sigma bond is breaking, here 1H, here 1H we can say. This is becoming what in the sense RCH2OH we can say. This is becoming what in the sense R dash OH we can say. So we are getting alcohol. Two alcohols we are getting. So ester on reduction gives two alcohols like this. What is a reducing agent here? In the sense lithium aluminum hydride in ether. Lithium aluminum hydride in ether we can use. Then catalytic reduction, nickel palladium platinum, nickel palladium platinum, anyone we can take, plus hydrogen. Okay, next one is diborane THF. Next reducing agent is what? In the sense diborane THF we can take. Diborane THF is a reducing agent we can take. Next alkali metal plus alcohol. Alkali metal plus alcohol is a reducing agent. Okay, next we will take anhydride. We will take, we are taking what? In the sense anhydride. We are taking anhydride. This anhydride on reduction gives what? In the sense alcohol. How we are getting alcohol, that we will see. This anhydride or CO or dash, it is the anhydride. Anhydride in the sense in the carboxylic acid, if you remove water you will get anhydride. Here let us break one pi bond, we will give 1H, 1H here. Let us break one pi bond, here 1H, here 1H. This sigma bond will break H and H. This sigma bond will break H and H. This becomes water. Therefore it is what? In the sense RCH2OH. RCH2OH. This is what? In the sense R dash CH2OH. Alcohol we are getting. So anhydride on reduction gives alcohol. Here what is the reducing agent? In the sense lithium aluminum hydride in ether. Lithium aluminum hydride in ether. Next catalytic reduction, nickel or platinum or palladium we can take, plus hydrogen we can take. Next reducing agent is diborane THF. Diborane THF we can say. Next reducing agent is alkali metal plus alcohol. Alkali metal plus alcohol is the reducing agent we can use. Okay, so next acid halide. Next we are taking what? In the sense acid halide we are taking. So acid halide we can write RC double bond O X we can say. Here this pi bond is breaking, here 1H, here 1H. This sigma bond is breaking, here 1H, here 1H. Therefore what we will get? In the sense RCH2OH. We are getting alcohol, or CH2OH alcohol we are getting. Here what is a reducing agent we can use? Reducing agent is lithium aluminum hydride in ether. Lithium aluminum hydride in ether. Ether is the solvent here. Next reducing agent is nickel or palladium or platinum plus hydrogen we can use. Catalytic reduction. Next reducing agent is sodium borohydride. Sodium borohydride in ethanol. Sodium borohydride in ethanol we can use it. So okay. Next we will take epoxide. We will take. Next we are taking epoxide. Okay. Next we are taking what? In the sense epoxide we are taking how we are getting alcohol here. We will see here this side bond is breaking H. This side bond is breaking H and H. Okay, H and H. Therefore what we will get? In the sense RCH CH2 CH2OH. Okay, like this we are getting. Now what is removed? In the sense OH will not be found, isn't it? Therefore here we want OH. Therefore what we have to do? Means we have to do like this. Therefore then only we will get like this. Okay, so we are getting another possibility also here. So what is another possibility, that we will see. So one alcohol we said, another possibility is what means like this bond breaking H and H. Therefore, another possibility is RCHOH CH3. It is another possibility. So here we will get like this two types of alcohol. Two possibilities are there getting alcohol in this epoxide. This is what in the sense epoxide we can say epoxide in the sense cyclic ether. Here what is the reducing agent in the sense lithium aluminum hydride in ether, lithium aluminum hydride in ether, then catalytic reduction nickel palladium platinum plus hydrogen catalytic reduction. Next one is diborane in THF. Diborane in THF we can use as a reducing agent we can use. Okay, so using these methods we can prepare what in the sense alcohol we can prepare. Okay, next one is using Grignard reagent. Okay, using Grignard reagent how to prepare alcohol, that we will see. So Grignard reagent into alcohol, that we will see. Now we will take what in the sense aldehyde we will take. In the aldehyde what we are taking means formaldehyde we will take. Okay, we are taking formaldehyde, we are treating this with the Grignard reagent. So what we will get? Okay, so we have taken what in the sense formaldehyde we have taken. So formaldehyde we have taken. What we will get, that we will see here. All formaldehyde or MgX we will write like this or MgX. So how the bond shift takes place? You see that this bond is shifting to R. This R minus is attacking this. This bond is shifting to this. Mg is attacking this. Therefore, we will get HCH. Here carbon is having R. This thing double bond becomes single bond. O is getting MgX. O is getting MgX. Then it is going for hydrolysis in the presence of acid or base. So how the reaction takes place, we will see. Here bond is breaking, Mg is having positive charge, therefore OH minus, oxygen is having negative charge, therefore H plus. Hydrolysis in the sense one side H plus, one side OH minus we have to give. Then what is the product we are getting in the sense RCH2 OH product we are getting. It is called what in the sense primary alcohol. So primary alcohol is the product. Okay. Next we will take aldehyde we will take. Okay, we are taking aldehyde other than formaldehyde we will take. Okay, so we are taking a what in the sense aldehyde, we are taking aldehyde other than formaldehyde, other than formaldehyde, because already we have discussed about formaldehyde we have discussed. Okay, so we are taking aldehyde other than formaldehyde. Now we are writing Grignard reagent. What is the product we will get, that we will see. Now the aldehyde in the sense aldehyde we are writing double bond O H, then Grignard reagent or MgX. Now this bond is shifting here, R minus attacking this carbon, pi bond shifting here, Mg is attacking this oxygen. Therefore we will write R dash C R, then OMgX. OMgX we are getting, it is undergoing hydrolysis in the presence of acid or base. So how the bond is breaking, we'll see. This OMg bond is breaking, H plus this side, OH minus this side. Therefore what we are getting means R dash C R OH. Okay, we are getting secondary alcohol. Okay, therefore if we take formaldehyde we will get primary alcohol. If we take aldehyde other than formaldehyde we will get secondary alcohol we will get. Then we will take ketone. Okay, we are taking ketone, ketone with the Grignard reagent. Ketone with the Grignard reagent, what we will get, we will see. Now R dash CO, R2 dash. Now Grignard reagent or MgX will take. How the bond migration is there, we will see. Bond is migrating towards R. This is attacking this carbon. Pi bond is migrating towards oxygen. Mg is attacking oxygen. Therefore, we will get R dash CO MgX. MgX, it is R2 dash, here R dash will be there. It is undergoing hydrolysis in the presence of acid. Okay, so how hydrolysis takes place, you will see. OMg bond is breaking, O side H plus, Mg side OH minus. Therefore, we will get R dash C, R2 dash, R2 dash we can say. Then what is obtained means here, here it becomes OH we can say. Here here OH, it is called what in the sense a tertiary alcohol. Okay, so ketone is giving ketone with the Grignard reagent. Ketone with the Grignard reagent, what we are getting in the sense a tertiary alcohol we are getting. Then we will take a epoxide. We will take epoxide with the Grignard reagent. We will see. Okay, now we are taking a epoxide. Epoxide we are taking epoxide with the Grignard reagent. What is the product we will see? Okay, so epoxide we will see here CH2. CH2 single bond CH2, here O, like this is there. Now we will take Grignard reagent. Grignard reagent we have taken. How the bond shift will be there, we'll see. This bond is shifting, it is attacking this carbon. This bond is shifting, this Mg is attacking this. Therefore, we will get this CH2 or this OMgX. OMgX. Okay. Then it undergoes hydrolysis in the presence of acid. So how the hydrolysis product is there, we'll see. This bond is breaking, H plus this side, OH minus this side. Therefore, we are getting a so and so alcohol. We are getting so and so alcohol. This is this alcohol. Which type of alcohol, primary or secondary or tertiary, in the sense that is depending on this epoxide. Okay, depending on epoxide, we will get a different type of alcohol we'll take. Next, we will take a ester. We'll take. We are taking ester like this. It is called what ester, in the sense formic ester. We'll take formic ester. We are taking Grignard reagent or MgX. Okay, so how the reaction takes place, that we'll see. Now this bond is shifting towards R is attacking this C. This bond is shifting towards here, Mg is attacking here. Therefore, we are getting a adduct. What is the adduct we are getting, in the sense this O becomes OMgX. This here R group comes, here O or dash. It is called what, in the sense adduct we can say. This is called adduct. Adduct we are getting. This is undergoing what, in the sense hydrolysis. It is undergoing hydrolysis in the presence of acid. So how the hydrolysis will be there? Here H plus is attacking, here OH minus is attacking. Okay. So like this attack will be there. Therefore, due to this attack, what we are getting? Then another place also hydrolysis takes place. That what hydrolysis, in the sense here also hydrolysis takes place. Here H plus and here OH minus. Okay. So because of this, now here what we have given, that is wrong. Here hydrolysis not taking place. We should not take this for hydrolysis. Why we should not take this for hydrolysis means before hydrolysis some other reaction also possible here. What is that reaction, that we will see before hydrolysis? Before hydrolysis some other reaction is possible. What is that means? This bond is migrating like this. This bond is migrating like this. Therefore, what we are getting, in the sense aldehyde we are getting what is leaving, in the sense MgX and O or dash is leaving. Okay. Then it is attacked by Grignard reagent. It is attacked by Grignard reagent. So how Grignard reagent is attacking means the bond is shifting like this. This bond is shifting like this. It is attacking like this. Therefore, we will get this O becomes OMgX. Here what is coming means R. Here what is there means H. This is taken for hydrolysis in the presence of acid. So what happens means here H plus we can say, here OH minus we can say. Therefore, we are getting a so and so alcohol we are getting. Okay. So we got which alcohol, in the sense we got secondary alcohol. We got what alcohol, in the sense secondary alcohol we got. Okay. Therefore, this formic ester gives a secondary alcohol. Remember that formic ester gives secondary alcohol. So formic ester gives which alcohol? Secondary alcohol. Now we will say formic ester gives secondary alcohol, we said. Now we will take ester, we will take this is what, in the sense ester. Ester means other than formic ester. Okay, other than formic ester. Okay. To this we will add Grignard reagent. We have written Grignard reagent. How the reaction takes place, you see, this bond shifting to R, it is attacking C. This bond is shifting here, Mg is attacking here. Okay. Therefore, what we are getting means R dash C O MgX. OMgX, here O R2 dash. Here what is there means R is there. Next, what happens means bond shift takes place. This bond is shifting here. This bond is shifting here. That means attacking this Mg. Therefore, what is leaving, in the sense Mg is taking X and O R2 dash and leaving. So what is obtained means R dash C double bond O R. So what we got, in the sense we got ketone. Then Grignard reagent is attacking this ketone. Grignard reagent attacks this ketone. This bond is migrating here. This R minus attacking here. This bond migrating to oxygen, and magnesium is attacking. So you will get R dash C O MgX. OMgX. Here R is there. Here what is there means R is there. This undergoes hydrolysis in the presence of acid. Therefore, what we are getting means R dash C R R OH. Okay. So we are getting what means a tertiary alcohol we are getting. So ester other than formic ester means a tertiary alcohol. Here to this carbon, two R groups introduced from Grignard reagent. Okay. Next, we'll take so ester with the Grignard reagent. We said ester with the Grignard reagent. This is about preparation of alcohol from Grignard reagent. We said next manufacture of methanol. Next we will see manufacture of methanol. We will see how methanol is manufactured industrially. That we will see. We will take wood. Wood is taken for a destructive distillation. Wood is taken for a which distillation? In the sense destructive distillation. On destructive distillation, what is obtained? In the sense CH3OH is obtained. Since it is from wood, it is called wood, and it is coming as a like gases. Therefore we will say wood spirit. We will say, okay, wood spirit will say, okay, spirit, wood spirit will say. Next method of manufacturing is carbon monoxide plus hydrogen gas in the presence of catalyst. What is the catalyst we are taking? In the sense zinc oxide, chromic oxide will take. Zinc oxide, chromic oxide. What is the pressure? Means 200 to 300 atmosphere. 200 to 300 atmosphere. What is the temperature? Means 573 to 673 Kelvin. Okay, so what we are getting means methanol we are getting. So carbon monoxide with hydrogen gives methanol. This methanol is colorless liquid. It is highly poisonous. Generally alcohol means ethanol is not poisonous, but methyl alcohol is highly poisonous. It what will happen? In the sense small quantity of methanol cause blindness, then high quantity of methanol cause death. Therefore it is a highly solvent. Therefore this highly solvent methanol is used as solvent in paint varnishes. In paints and varnishes, this methanol is used as a solvent. Okay, next we will see ethanol. Regarding ethanol, in the sense denaturation of ethanol. Denaturation of ethanol will see. In the ethanol we are seeing denaturation of ethanol will see. What is denaturation of ethanol? In the sense we have to take ethanol, we have to take, to this we are adding copper sulfate. In order, this copper sulfate gives color to this ethanol, and we will add pyridine. We will add pyridine. We are adding this pyridine is having what smell? Means a foul smelling liquid. This pyridine is a foul smelling liquid. Foul smelling liquid, pyridine. Okay, denaturation of ethanol. Why we have to denature the ethanol? Ethanol is used as a solvent in industry, but it is used in a wrong way. Therefore in industry means for industry it is given as solvent. Therefore for less cost it is given, but it is handled in a wrong way. In order to avoid that, what they will do? In the sense for industries how ethanol will be supplied? In the sense by mixing with the pyridine and copper sulfate. Pyridine is giving foul smelling. Therefore on opening this foul smelling we will get therefore people will not consume this. So in order to avoid that, in order to avoiding consumption, this ethanol is denatured. This nature is spoiled. That means denatured. So that denaturation of ethanol, in the sense we are adding copper sulfate in order to give color, and we are adding pyridine. It is having foul smelling smell, that is added here. Okay, so this is about denaturation of ethanol, we can say. Next some more methods of preparing alcohol from the alcohol from Grignard reagent, that we'll see. Some more methods also we'll see. Okay, now some more methods of preparing alcohol from Grignard reagent we'll see. Now we will take a formyl halide. We are taking what? In the sense formyl halide we are taking. We are taking formyl halide. Okay, formyl halide we are taking. This is treated with what? In the sense Grignard reagent. It is treated with a Grignard reagent. So what is the product we will get? That we will see. Now this bond is shifting towards R. This is attacking this. This bond is shifting here. Mg is attacking this. Therefore, what we will getting means HC, single bond O, single bond MgX. Here R group comes. Here we can say Cl. Next step is not hydrolysis. Here exchange takes place. This bond is coming here. This bond is coming here and attacking Mg. Therefore, what is leaving? In the sense Mgx and Cl is leaving. So what we have got in the sense RCHO, aldehyde we got. Aldehyde reacting with the Grignard reagent, then with hydrolysis in the presence of acid. So what you will get means secondary alcohol you will get. Okay, therefore formyl halide gives a secondary alcohol. Sir, next we will take a acid halide. We will take acid halide other than formyl halide. Okay, so we have taken a acid halide other than formyl halide will take. Acid halide other than formyl halide will take. This is treated with a Grignard reagent. treated with the Grignard reagent, what is happening? You see, this bond is migrating to R, this R is attacking here, this bond is migrating, Mg is attacking this oxygen, therefore we'll get this R dash C O is making bond with Mg and X. In this C, R group comes here, Cl is there as it is. Next, what interchange takes place is this bond comes here, this bond goes here, bonding with Mg. Therefore, what is leaving in the sense MgXCl is leaving. So what we are getting in the sense we are getting ketone. We have got ketone. This ketone is reacting with the Grignard reagent. Then on hydrolysis in the presence of acid, what we are getting means tertiary alcohol. We will get what means a tertiary alcohol. In this acid halide, one R group is there, but here three R groups, two more R groups from Grignard reagent. So acid halide other than formyl halide, in the sense we are getting a tertiary alcohol we are getting. So we got a tertiary alcohol we got. Now we will take a formic anhydride will take. We are taking what in the sense formic anhydride. Now we are taking a formic anhydride. Formic anhydride means formic acid. Formic acid formic acid reacting and liberating water and gives formic anhydride. To this, what we will add in the sense Grignard reagent we will add. So we are adding a Grignard reagent into this. This Grignard reagent, how the bond shift takes place, you will see it is shifting like this. It is attacking here, then it is attacking this one, and it is shifting like this. So we will get a HCr group here. This O becomes MgX, and here O and C double bond O H, like this will be obtained. Okay, so next what is happening, that point we will see. Next step is what in the sense you see that this bond is migrating here, this bond is migrating here, and attacking this Mg. Okay, therefore what is leaving in the sense HCOO MgX, X is leaving. So what is obtained in the sense aldehyde is obtained. Aldehyde is reacting with the Grignard reagent, and hydrolysis in the presence of acid gives what in the sense secondary alcohol. We are getting what in the sense secondary alcohol we are getting. Set. Now we will take a acid anhydride. We are taking a acid anhydride in the sense RCOO R dash. So now it is treated with the Grignard reagent. So what we will get, that we will see. Now this bond is shifting here, this is attacking here, this bond is shifting here, Mg is attacking here. Okay, so we will get RCOMgX. Here what is there means R is there, here OCO R dash is there. Okay, therefore how the bond shift takes place, now we will see. This bond is shifting to this place, this bond is shifting to this place, it is attacking Mg. Therefore what is leaving in the sense MgX, this OC double bond O R dash is leaving. So what we are getting in the sense RCOR, ketone we are getting. This is treated with the Grignard reagent and then taken for hydrolysis in the presence of acid. We are getting tertiary alcohol. Therefore, acid anhydride with Grignard reagent, we are getting what in the sense tertiary alcohol. We are getting formic anhydride on a Grignard reagent. What we are getting in the sense secondary alcohol we are getting. Sorry, okay. Next, up to now we have discussed about alcohol. Now we will discuss about phenols. We are discussing about phenols. Preparation of phenols we will see. Now we will take chlorobenzene. Chlorobenzene will take. Chlorobenzene is treated with the sodium hydroxide at what condition means 623 Kelvin and 300 atmosphere. Why we have to give high pressure? We have to give in the sense chlorobenzene between carbon and chlorine partial double bond is there. Therefore, it will not go for nucleophilic substitution reaction easily. Therefore, in order to force them to undergo nucleophilic substitution reaction, we are providing high temperature and very high pressure we are giving. Therefore, we are getting what in the sense sodium phenoxide we are getting. This sodium phenoxide is treated with what in the sense HCl. We are getting what in the sense phenol. Okay. So why we are getting phenoxide? This Cl is replaced by OH minus no. Then we will get phenol only, no, we can say. But this phenol is acid. It can react with the sodium hydroxide base to give sodium phenoxide. Therefore, next we will take a benzene. We have taken benzene. It is treated with what in the sense oleum. So oleum in the sense what is oleum? Oleum is nothing but H2S2O7. It is nothing but what in the sense concentrated sulfuric acid plus SO3. So SO3 is there means SO3 can act as electrophile. SO3 can act as electrophile. Benzene is going for electrophilic substitution reaction with this SO3. So how this reaction will be there? That point we'll see. Now we'll take benzene. We are taking benzene here. Will give pi bonds. Will give SO3. We can write it as like this. SO3 we are writing like this. So what is happening? You see that this pi bond is coming out. This pi bond is attacking the sulfur. This bond is shifting like this. Therefore, we are getting this benzene. We will write here carbon, here one nitrogen, here S, here O minus, double bond O we can give, and pi bonds we can give like this. Okay. Next, what is the next step? We will see. Here, what is the next step in the sense this bond is migrating here. So due to that, what we are getting in the sense here benzene, here pi bonds we will give, and it is what in the sense like this we will say. Okay. Next, it takes H plus from water. Water becomes OH minus. Therefore, we will get what in the sense SO3H. SO3H we are getting. It is called benzene sulfonic acid. It is called benzene sulfonic acid. Here, what is the sulfonating agent in the sense oleum, otherwise concentrated sulfuric acid. Concentrated sulfuric acid. What is the electrophile in the sense SO3? This electrophile is not having positive charge. Okay. In this case, electrophile is sulfur trioxide. Sulfur trioxide is not having any positive charge. Okay. Next. Now it is called a benzene sulfonic acid. We can say it is benzene sulfonic acid. It is treated with what in the sense sodium hydroxide. Benzene sulfonic acid is treated with sodium hydroxide. What we are getting in the sense sodium phenoxide. It is called sodium phenoxide. We can call this as a sodium phenoxide. So how benzene sulfonic acid gives a sodium phenoxide, that we will see. It is benzene sulfonic acid. How it is giving a sodium how it is giving a sodium phenoxide, that we will see. Okay. Now benzene sulfonic acid we will take like this. Benzene sulfonic acid we are taking like this. Okay. Now we can say this oxygen is high electronegative, therefore bond is going like this. Therefore this bond is shifting like this. Okay. So what happens? You see that what happens in the sense here pi bonds, here positive charge, here double bond, here O minus, here double bond O, here OH. That means this sulfonic group is acting as electron withdrawing group. It is acting as electron withdrawing group in the sense it is making electron deficiency in the phenyl ring. The sulfonic acid is the electron withdrawing group. Because of this electron withdrawing group, here electron deficiency is created. Electron deficiency is created means this nucleophile, this OH minus is a nucleophile. Nucleophile can attack easily this one, isn't it? Nucleophile is easily attacking. Therefore only nucleophile is attacking in the sense when this phenyl ring is attacked by OH group. This phenyl ring is attacked by OH group. Sir, okay. Then what about the sulfonic acid? What about the sulfonic acid? What happened to the sulfonic acid? That point we will see. Now here sulfonic acid will take. Sulfonic acid we are taking. Now what is reacting means sodium hydroxide is reacting. Sodium hydroxide is reacting. It is taking this H plus. Therefore what we are getting in the sense SO3 minus. We are getting what in the sense SO3 minus we are getting. Okay. SO3 minus we got. We got SO3 minus in this case. Sir. So we got SO3 minus we can say. Next what is happening means here this lone pair is shifting, this bond is shifting here. Okay. So like this happening. Therefore from this SO3 is leaving. SO3 is leaving. Okay. SO3 is leaving in the sense this SO3 is leaving. Therefore desulfonation takes place. SO3 is leaving. Therefore benzene sulfonic acid on treating with sodium hydroxide, two reactions possible. One is desulfonation. Another one is what in the sense nucleophilic substitution reaction. Therefore we will get phenol reacting with sodium hydroxide to give what in the sense sodium phenoxide. This sodium phenoxide treated with HCl, what we are getting in the sense phenol we are getting. Okay. So we got phenol. So next reaction we'll see. Now we will take in the preparation of phenol another reaction. We will take aniline. We'll take aniline. This aniline is taken for diazodization. Diazodization means treated with NaNO2 and HCl. 0 to 5 degrees Celsius temperature is given. So what we are getting in the sense of benzene diazonium chloride we are getting. So we got